Welcome to another session of microengineering. In today's session, we are going to actually learn about magnetron equations. The first equation we are going to learn is about the cyclotron angular frequency. Please note that electrons are under the influence of electric field and magnetic field. Magnetic field is present in the anode cavities and electric field is present in the interaction space. So there is some sort of a centrifugal and centripetal force which is coming, and both the forces are going to be equal to each other, and this in form of equation we have written it as mv squared by r is equal to bev. This you have stated according to physical laws. So when on solving, you get a frequency at which this is going to happen is omega c. That is called as cyclotron angular frequency. Formula is given as be by m. What is b? Magnetic flux density. As we have seen in the earlier slide, that cyclotron angular frequency was omega c equal to be by m. Please note, only b, magnetic flux density, will be given in the papers. E by m value should be known to you. It is 1.759 into 10 to the power 11. Now, in this case, we are going to divide the entire derivation into three subparts. Subpart number 1 will be under magnetic field influence, second under electric field influence, and the third will be equalization, that is under electromagnetic field influence. Let us take the first one, under the influence of magnetic field. Now what happens in the influence of magnetic field? According to cylindrical coordinate system, we start the derivation by writing 1 by r d by dt of r square d phi by dt equal to omega c dr by dt. Now in this case, when we are writing, we have to find integration of this derivation. As a result, we are going to do slight adjustment. What is the adjustment? We are going to write over here as this d by dt r square, this dr by dt which is there, this can be written as, can you all see over here? This can be written as, I have solved it for you all, it can be written as d by dt of r square is, we get it as 2r dr by dt. So r dr by dt can be written as half d by dt of r square. Am I right? So we are just going to substitute over here d by dt of r square d phi dt. This r has come from here, from the left hand side. We have just multiplied it upstairs so that it comes in this form. We got the equation as omega c r dr by dt. On integrating both the sides integration sign gets vanished, and you get r square d phi by dt is equal to omega c by 2 d by dt of r square. Now this is a definite integration, so we are going to find a constant. Now let us see how we are going to find the constant. To find the constant, we are going to start with at radius r equal to a, your angular velocity is going to be 0. Why are we doing this assumption is that we are going to have two types of velocity in magnetron. One is angular velocity, another is going to be your, what is it called as, radial velocity. So one time we'll take angular velocity to be 0, another time we're going to take the radial velocity to be 0. So right now I'm going to take angular velocity to be 0 at radius r equal to a. Don't get surprised with that. We are going to have two types of circles. If you remember, we are going to have here cathode and here was your anode. So I'm going to assume that this radius is going to be a and the other one is going to be b. At r equal to a, angular velocity equal to 0. So I'm going to substitute that equation. Can you see over here? When I'm going to take this as 0, what happens? R is equal to a, I have substituted. So k becomes equal to minus omega c by 2 into a square. On substituting in the original equation, you get r square d phi by dt is equal to omega c by 2 r square minus omega c by 2 a square. This was your constant. So your final equation comes omega c by 2 r square minus a square. Please mark this equation as 1 because this is under the influence of magnetic field. Now let us see for the influence of electric field. When we take the influence of electric field, we start by saying that half mv square is equal to ev naught. What is ev naught? Remember, kinetic energy is equal to potential energy. So from this, v square is equal to 2 e by m into v naught. We are taking again radial as well as your angular velocity. So as I told you in last slide, dr by dt is radial, and you're going to have the angular as r d phi by dt the whole square. It is equal to 2e by m. Last time we had taken angular velocity to be 0. This time we have taken radial velocity to be 0. So what happens? This factor automatically gets cancelled. What remains at r equal to b? So we are substituting b d phi by dt the whole square is equal to 2e by m into v naught. Please remember, mark this equation as 2. Now we are going to equate both the equations. Now we are going to take the influence of electromagnetic. So what do I do? We are going to substitute R equal to B in equation 1. I hope you remember that was under the influence of magnetic field. So when I am substituting, I am getting B square d phi by dt equal to omega c by 2 B square minus A square. Squaring both the sides, it becomes B raised to 4 into d phi by dt the whole square omega c square upon 4 B square minus A square. Don't get worried about this step. We are just going to take this B square outside so that it becomes 1 minus A square by B square the whole square. B raised to 4 comes out. Okay, so in this case, when I'm substituting this equation, you can see over here, what is this? So this equation is b square. This is a mistake. This should be b square. What we are doing is this b raised to 4. Can I write it as b square into b square? So when this becomes b square into b square into d phi by dt the whole square, already you know by equation number 2 is this. So we're just going to substitute that. So after substituting that, you get the final equation as b square into 2e by m b naught into omega c square by 4 b raised to 4. This is what you know. What is omega c by the way? What is omega c? Cyclotron angular frequency. So we will substitute that capital B into e by m the whole square over here, and finally you get the equation of V naught, which is called as, remember this, it is called as Hull cutoff voltage, or it is called as critical voltage or cutoff voltage. I repeat, it is called as Hull cutoff voltage or critical voltage or cutoff voltage. Okay, this is a Hull voltage. So if you want the electrons not to enter the anode cavity, the applied voltage should be always greater than VOC. You can write over here a VOC. It's a critical voltage. The applied voltage should be greater than VOC. If you can find VOC, can you find BOC? What is BOC? We have not substituted over here. But this omega C, if you substitute BE by M, you will get the formula in terms of B. We'll see in the next slide. Yes, in this slide, the formula is written in terms of BOC. I hope you remember how did we arrive at this formula, because we substituted omega C as BE by M. In Samuel Lear book, this entire derivation is given, but it's not explained thoroughly. That's why all the steps have been written by me and explained in detail. You can go through this slides. And same way, if you want to check for the BOC, remember the applied magnetic field should be always greater than BOC so that the electrons will not reach the anode. I hope you understood this lecture. We can see a problem. Thank you. The problems are very simple. In this problem, we are going to find about same thing, BOC. We are supposed to find VOC over here, Hull cutoff voltage or critical voltage. We call it as cutoff voltage or critical voltage or Hull voltage. You are asking us to find magnetic flux density B for Bombay, VOC for a fixed. Formulas are known to you. You know the value of omega C. I hope you remember. What was it? BE by M. So here V naught is given to you. You just have to substitute E by M. By the way, do you know the formula for E by M? I hope you remember it. E by M should be 1.759 into 10 to power 11. This should be known to you. Multiply, get the value of omega C. Cutoff voltage formula is already derived for you all. Substitute, get the value. Then again you can find the value for BOC when the VO is given. You can expect such problems in paper for 10 marks. Thank you.